with day 2 of this section. So again, couple of reminders. Now write them in on these first couple of examples as we kind of kickstart. When we're looking for x-intercepts, we are setting the numerator equal to 0. Sometimes that may mean we have to factor. So for instance here, if I set the numerator equal to 0, ooh, I do have to factor this. But luckily it's just a little bit of mental math, a little bit of like a diamond type of what multiplies to -3 but adds to -2. What might that be?
1, 2, 8.
Yes. We're trying to figure out what multiplies to -3 and adds up to -2.
3 and 1.
-3 and 1. Bless you. And then we just set those equal to 0 and get our x-intercepts, which would be at -1 and 3. So I'll go ahead. Got me a couple of freebie points for my graph here.
Doesn't matter which order it goes in.
Nope. No matter on the order. So we're like, all right, so what else have we got here? Vertical asymptotes. We set the denominator equal to 0. So we're like, okay. So x squared minus 4, difference of squares, or you could do it algebraically, add 4 to each side and take the square root. Either one will get me to the same place at the end. What would this look like in its factored form, though?
Oh, x to -2 and x to 2.
Okay, yeah, +2 and -2, because 2 squared is 4, but I want the minus in there, so one of them needs to be negative. So for my vertical asymptotes, since they're lines, I need to make sure I put x equals with those. And as I get that done, I'm going to go ahead and I'm going to draw my asymptotes in, because again, they're like walls. They help me to figure out, okay, where is my graph going? Or where can my graph go? It also lets me know if I do go to the calculator, what exactly, you know, things should look like. So now, horizontal asymptotes
1.
is going to be 1. Now, why is it 1? You're right, Ben.
Because the coefficients, the leading coefficients are both 1, so 1 divided by 1.
Right. Since they're equal weight, since they have an equal degree, and I find that by looking at the largest exponent, since they're the same, I just divide their coefficients, and 1 divided by 1 is 1. So I have a horizontal asymptote at y equals 1. And in these, when I have a horizontal asymptote, I won't have an oblique. We'll get to the obliques here soon. These are always slanted though, it's kind of... So, once I get here, now I feel pretty safe going and checking with the calculator to see what's up. And there it is. So now, if I want to check and see what's going on, remember, when you go to type it, we're going to use parentheses to make sure the calculator understands, okay, I've got a definitive numerator and denominator here. Don't go just following your own order of operations, because that's not what I want you to do. Okay. Oh, and then I just talk about that, and what do I almost do? I almost do the same thing myself. So once I get that typed in and I graph it, I should be able to look at what I have and see some similarities. Reminder from yesterday, these vertical lines that you see going upward, okay, those are not your graph, okay, those are your asymptotes. You've already got them drawn in. that's okay. For a lot of you, that's probably going to be better if they don't show up, because you're not going to be tempted to want to blend them into your line and all of a sudden make it part of your graph. So if you don't have them, no big deal. But you start to notice, you're like, okay, so this graph looks kind of funky. Because here's my branches like I normally had. But then, ooh, check this out in the middle. Okay. So not only do we get our regular hyperbola going around the outside, but we get something sort of like an x cubed type graph. Kind of interesting. So here's how we're going to figure out how to graph this somewhat accurately. Because some of you may be wondering, well, wait a minute. We've got this asymptote here, and these guys, oops, come back. These guys are hugging it, but how is this going straight through there? Because I have an asymptote here. You know, what's the deal? What ends up happening sometimes with your horizontal asymptote, you can have a point, one random one, go through there sometimes. Your whole line won't, but on those, in a case like this, you will have a value that goes through. So when I go to actually graph, okay, again, my vertical asymptotes will come up as error, so 2 and -2, that's good. That kind of lets me see that I've done things correctly. And we said when we were going to graph these, we were going to use 2 points to the left and 2 points to the right, at least, to try and make this look good. So since my first asymptote's at -2, I'm going to use the -3, 2.4, and the -4, 1.75, just those couple of dots to give me a head start on putting my branch in there. And again, your branch is going to hug the asymptotes, both of them. So try and get as close as you can with that. I'm going to swing over to this one for a second, because this is the other normal looking branch that I'm going to get. So again, I'd be looking at 2 values after my error, which is my asymptote, so 3 and 4. Well, 3 I already have. It's an x-intercept, 3, 0. So then for 4, it's almost up to a half. And then again, we're just sketching, but we're kind of somewhat accurately sketching. So I've got my 2 branches. Now comes the interesting part. What about that stuff that's going on in the middle? Okay, between my 2 branches, between my -2 and my 2. I personally would go ahead and plot all of those points. Well, I've already got the -1, 0 right here. So at 0, I'm at 0.75, and at 1, I'm at 1.33. And if I need some help reminding myself, well, what's this going to look like, I can go back to the graph and say, oh yeah. And here's where some special stuff starts. I'm like, okay, I got all this crazy graph drawn. Now what? Well, I've got to deal with my domain and range. Well, domain, we sort of got a preview of that with that example problem we did before we even started. My domain, my x values go from left to right. The only time they get cut off is when I have a vertical asymptote. So, what's the first part of my 3-part domain going to be? Okay, -infinity to -2, which is my first asymptote. So then we get cut off, so we got to start up again. Start up again at -2. Where am I going to go till I get stuck again? I get stuck again at 2, because that's where my next asymptote's at. So I'm like, all right, I'm going to keep going through, though, because there's more value over here. Start back up at 2. Head off to infinity. It is. It looks really weird. You're like, why can't I just write, it's every number but 2 and -2? Technically we can, but as you get more to the upper level math, everything goes into interval notation. Instead of just saying, you know, all reals but this and that. So it's just, it's good. It's a good practice to get into. Now the range is the weird one. Yes, because normally we would say it's negative infinity to 1 and then 1 to infinity. But we notice here our graph goes straight through it. So the graph kind of breaks through our barrier, and our range ends up being a special case here because we can see right here this graph heads off to negative infinity and it never stops heading up to positive infinity. So if you do get a part of your graph that breaks that horizontal asymptote, your range can break right through it as well. So you've got to watch for the special cases a little bit. You've got to actually look at your graph, see what's going on, and kind of make an adjustment. So they can be kind of strange. It's definitely true. Definitely true. Any questions on 2? Because I'm going to start throwing the weird ones in here, just so you can not worry too much here. You're like, eh. Okay. Number 3. All right, so I start to look at this one. X-intercepts. We set the numerator equal to 0. Wait a minute. I can't set 4 equal to 0. It doesn't work. That means there are going to be no x-intercepts this time. This graph will never cross the x-axis. That seems kind of strange. What's it going to look like? We'll see here in a minute. So then I get to vertical asymptotes, where I set the denominator equal to 0. And I start looking at that, and I'm like, well, wait a minute. That's not a difference of squares. That's positive. Well, when we did that before, I started coming into this. Because if I tried to solve this, I'd get x squared equals negative 1. But I can't square a number and get negative 1 unless I do I. So this would mean I'd have imaginary solutions. Well, we can't graph imaginary numbers, at least not on this. So I have no vertical asymptotes. Dang. Is there going to be anything on this crazy thing? There will be. So I get to my next part. Horizontal asymptotes. Now, if I don't see any variable up top, we can do one of two things. Either I can assume that this is x to the 0, which would make it top heavy. Like now what is, excuse me, bottom heavy. I'll get this right yet. If something is bottom heavy, in other words, the exponent in the bottom is bigger than the one in the top. Now let's come back here for a minute. What's that mean? Bottom heavy. If the degree in the denominator is larger than the degree in the numerator, the horizontal asymptote is y equals 0. Okay. Sounds like a plan to me. No other calculating to think about? Horizontal asymptote, y equals 0. So the only asymptote I have is right along the x-axis for my y equals 0. And again, when I have that, I will not have an oblique. You're like, dang it, are we ever going to have obliques? Yes, we will.
Keep working out.
Yeah, keep working out. So you're like, well, I really don't have a whole lot of info here. This is going to be kind of weird. So, all right, let's take a look and see what this is going to look like. So we've got 4x. Oh, no, not 4x, Hardy. No. 4 over, remember my parentheses, x squared plus 1. All right, let's see what this sucker looks like. Kind of looks like a bell or a hill or, well, I don't know. So there's no real rhyme or reason to things. I see it doesn't go through x ever. I can see why it says we don't have any vertical asymptote. So what's the deal? Well, let's in this case head to the middle, head to 0, and start plotting some values so we can at least get an accurate idea, because it looks like, looks like this is going to be symmetrical. So I'll just get a few points in here so I can be kind of accurate. Still going to hug the asymptote. We're going to get a little bell shape in the middle, which should make figuring out my domain and range something that's not too hard to do. So domain, Any restrictions on my domain?
9.
No, because it just has that little bump and it keeps right on going. So domain, all good everywhere. Any restrictions on my range as I go from bottom to top of my graph? Is there any restriction on the bottom? What's the lowest y value I'm ever going to run it towards?
0.
0. Any limit to where the top may end up? Thought I heard it. 4. So my range, that's kind of narrow for this one. Okay? So we've got to be a little bit flexible with these to see how this works. All right. Now I'm going to come with the 2 craziest ones. We're going to skip 4 because that's still somewhat too normal. Let's go over to 5. Here comes the craziness. Those of you that are waiting for obliques, here they come. So, again, x-intercepts, set your numerator equal to 0, and factor that sucker.
3 and 1.
All right.
3 and negative 1. Whoa. Other way. I was keeping the
So when I factor this out, I get x minus 3 and x plus 1. And if I set those each equal to 0, I end up with x-intercepts at 3 and negative 1. So that gives me a start. Vertical asymptote, set the denominator equal to 0. So that one actually is pretty straightforward. So x is going to be at negative 4. So I'll get that drawn in. Now is when the fun starts. Horizontal asymptote. Look at your degree in the numerator and the denominator.
2.
2 is bigger, which makes this top heavy. First time we've dealt with that. Exponent's bigger on top, it's top heavy. Well, what does that mean? Well, let's see here. Top heavy. There is no horizontal asymptote, but there is an oblique asymptote. All right. So, horizontal asymptote, in this case, is none. So how do I find an oblique? Here's how it works. We're going to do a little long division here. Oh boy. But we don't worry about the remainder. So here's how this bad boy is going to work. I'm going to take my x plus 4, and I'm going to divide it into the x squared minus 2x minus 3. Now, here's how it works. First term into first term. How many times does x go into x squared? Or x times what gets me x squared? X. Okay, we're just looking at the first terms here. So x times x is x squared. Once I get that, I'm going to multiply the x times the x
4x.
and times the 4. And once I've done that, once I've distributed that through, we're going to subtract those values, because my whole goal here is to eliminate that first term. So I'm like, okay, negative 2 minus 4 is negative 6x, and I'll pull my minus 3 down, and I run the process one more time. It's always first term into first term. Yep. X times what gets me to negative 6x? Negative 6. And then again, I distribute. So negative 6 times x is negative 6x. Negative 6 times 4 is negative 24. And when I subtract, the x's cancel. And you're like, well, okay, so 21's my remainder. Don't care. I just want to make sure I get to the end. Whatever this is, and here's where the fun starts,
30.
that is my oblique asymptote. It's actually going to be a line. So here's how this works. X minus 6, or if you want to put, I'm not going to put this in for every time, but just so you think about it this way. If you were to go graph the line y equals x minus 6, that's exactly what we're doing, but we're making it an asymptote. So here's how it goes. Go down 6, put a point, just like you normally would if you were graphing the line. My slope is 1 over 1. So up 1 and over 1, up 1 and over 1, get myself a little bit of a start here. And instead of totally connecting them, an oblique asymptote is also sometimes called a slant asymptote, as you can see here, because it slants. You're like, what the heck is this crazy thing going to look like? So once I get to this point and I've got my asymptote set, now let's see what it looks like. All right, so we have got x squared minus 2x minus 3 and x plus 4. All right, let's see what you look like. Oh, and I can start to see why this works the way it does. If you have your asymptote where it's set on your calculator, you see that here, you're like, okay. But then you notice how my graph has a slant to it, this direction. So what would happen is, I'm going to end up with values, if I look at my table. So I'm like, okay, so here's my asymptote at -4. Let me get my error up so we can see that. There it is. I'm going to plot my other points. So -3, 12. I'm going to be just about out of room here, but up here. -2, 2.5. I've already got -1. And I start to notice, as I put some of these down here, it gets kind of lower and lower. And it's going to start working its way back up. Now again, I'm not looking for perfection here. I do want something that's going to be fairly accurate though. So I'm just kind of curious, as the numbers get bigger, what's happening here. And you start to notice, if I just put a value out here, it's a little bit further, that my branch is going to start getting closer and closer to that slant asymptote. What you don't see this time is, normally there's stuff going on the other side. Is there nothing going on over here? Is it just like wasteland? There's nothing at all? Well, let's take a look. Let's say our y minimum, I don't know, let's go -40. And again, I'm just coming up with some values so I can see a little more. Oh, there is something going on down here.
Oh.
Now, on my graph, as far as this goes, that's going to be kind of hard to see right now. Okay? Could be a little bit trickier. I wish I'd have had a graph I'd have put a little bit bigger here. But here's how we're going to deal with this. When I'm trying to figure out my domain and range, I'm thinking left to right, and that still is going to be the same because I still have my asymptote here. So my domain isn't going to change much from what it has. It just basically, my vertical asymptotes are going to be my cutoff points. Again, the range becomes my issue. Because as I can see from this picture, there's a gap in here that my graph isn't going to cover. So that kind of makes life a little bit difficult here with this slant asymptote. So here's what I would have to do in a situation like this. This is the one thing that can get a bit tricky. I need to find a max and a min. You're like, oh, max and min, that's coming back. It is. So here's what we're going to do. I'll get my window back to normal so some of you are seeing what I'm seeing here. So you can see how this works. Okay. So we're dealing with, here's my minimum right in here. So I've got to figure out what that is. So second trace gets me to my calculate menu. And since it's opening up, it's a minimum that I'm looking for. So I'll go down to minimum, hit enter so the calculator knows what I want. And this is one of those things, again, we're going to trap the minimum in. As long as your little cursor guy is anywhere to the left of that minimum, doesn't matter where, and you hit enter, then it'll ask you for the right bound. So again, anywhere to the right of that dip. Doesn't matter if it's here, way out here, doesn't matter. Because what I'm doing is I'm giving it 2 endpoints and I'm finding that value in the middle. So I'm going to hit enter once, and then it's going to ask me for a guess. I really don't care if I guess or not. I'm just going to hit enter again. And whatever that minimum value is, okay, it's the Y value I'm looking at because it's the range that I'm looking at here. I want to make note of this because what I'm going to do with that, let me swing this over, is the last part of my range will go from that negative 0.83, excuse me, off to infinity. The question now becomes, how do I find the other half? Because we saw when I changed the window before, there's another part to this. So that's when I say, okay, let's mess with the window here. Looked like it was going to work okay before when I went my Y down to negative 40. I don't really need to change my max. So let's see if I can see it still. Okay, I see it right here. So what I'm going to do is once I change that, I'm going to go back and I'm going to do the same thing I just did for the min, except now I'm going to make it a max. So second, calc. Now I want a max. Okay. And you'll notice, you're like, well, my cursor guy's way up here. What? Just keep going left. It's going to take a minute. He'll start popping up here. There he is. But I'm trying to make sure, because my maximum's in here somewhere. So I need to make sure I'm to the left of it here. So I'm going to get right to the edge of the screen here. So he's to the left of this point here. So hit enter once. To the right, anywhere to the right's good. Doesn't matter. This is good. Over here it'd be good. As long as I'm to the right. And once I get there, I'll just hit enter twice again. So my maximum, and again, it's the Y value. So I'd have negative infinity to negative 19 point, well, you can call it 19.2. And then it cuts off and it starts up again later. So you can have these break up some. So do not panic if something like that happens to you, okay? So here's the deal. I know these take more time than the ones yesterday did. I am thoroughly and completely aware of this. So here's how this is going to work today.
Finish the rest of the packet?
You do not need to finish the rest of the packet, because it just kind of goes into some of the same things again. So here's our game plan today. Shrink the calc down. Going to be on 550. We're going for 12, 16, 18, 26, 30, and 35. Now, the only 3 you're graphing are the last 3. And even though it says just graph, guaranteed one of the questions I'm putting up here is going to be on the homework check. I want to know the x-intercept and all asymptotes besides graphing on those 3. So 6 monstrously ridiculous questions. No, just kidding. 6 questions. Monday, we will be doing a quiz preview in class together. We are going to do a one-section quiz on Tuesday, which is also when the next homework check will be, which will include yesterday's book work, today's book work, and the quiz preview that we do on Monday. And then we will get back into the world of factoring and away from graphing for a while.
Thank gosh.